Now we will discuss about the theory of colors, how color is made and how it is divided into different parts. So in the study of physics, color is defined as the sensation received by the rods in the eye due to light coming from an object, and as rods can sense only three colors named blue, green and red, and all spectral colors will be produced by mixing these in proper proportions. Because our rods in the eye only sense three colors, we have to keep in mind that blue, green and red, and these spectral colors blue, green and red are called primary colors. The color produced by mixing any two primary color is a secondary color. Depending on primary colors mixed, we are flowing three secondary colors. For example, when we mix blue and green, we get cyan, and when we mix green and red, we get yellow, and when we mix red and blue, we get magenta. And a secondary color and remaining primary color are said to be complementary colors, that is red and cyan. Similarly, blue and yellow and green and magenta are complementary of each other. We can also say that oh, the presence of all the wavelength of visible region or all primary colors or all secondary colors or complementary colors gives the sensation of white, while their absence black, above all in the form of a triangle called color triangle. The perception of a color by eye depends on the nature of object and light incident on it. This is why a body looks of different colors in different light, and different bodies in same light appears to be different colors. Now colors of opaque objects. It is based on reflection of selective wavelength by an object whose interaction with eye gives the perception of a particular color. Example: if a rose appears to be red in white light, it reflects red only and absorbs all other incident wavelength, and hence will also appear red in red light but black in light of any other colors, say blue or green. Now some important point regarding this. If a bunch of flower is illuminated by sodium light, yellow and white flowers will appear yellow, while all other dark, because sodium light is yellow. So yellow and white colored flower will look yellow, but other colored flower will look black. Mercury light is deficient in red. So if a red object, say red tie or lipstick, is seen in mercury light, it will appear dark. A white screen will appear green in green light and red in red light, as white reflects all wavelength. However, if beams of green and red lights are incident on the same spot of a white screen simultaneously, the spot will appear yellow, as green plus red becomes yellow. If an opaque color glass or crystal is crushed to fine powder, it will appear white in sunlight, as it will lose its property of selective reflection. Next, when white clothes become yellowish, we add indigo to produce whiteness, as blue is complementary to yellow. That is, yellow plus blue gives white. Because blue is primary color and yellow is the secondary color. And yellow in secondary color yellow, blue is not included. So when we mix yellow and blue, it makes white. The colors of opaque object in reflected and transmitted light are complementary to each other. Example, gold appears orange yellow in reflected light. So if made very thin, it will appear bluish green transmitted light. Now, first we have discussed colors of opaque objects. Now we will discuss colors of transparent objects. And it is based on transmission of selective wavelength by an object whose interaction with eye gives the perceptions of particular color. Let points related to this one by one. First, if we look an object through a green glass or green filter which passes green light only, green and white objects will appear green while all other black. If a red cross or a white black background is seen through a blue filter, the white background will appear blue and the red cross black. However, if same is seen through a red filter, both background and the cross will appear red, and hence cross will be invisible against a red black background. If a copper coin is placed in copper sulfate solution and is seen in white light, the coin will appear black. This is because copper sulfate will act as a blue filter, and hence light incident on copper coin will be blue, and as copper coin in sunlight is reddish, that is reflects red, it will absorb blue and hence will appear black. Next point, if a body transmits all the wavelength of visible region, it will be colorless. Now we see the colors of pigment and dyes. The theory of colors of pigment is totally different from that of opaque object. Paints and pigments reflect light of more than one color, and when they are mixed, the resulting color will correspond to common reflected wavelength. Example, a blue pigment reflects blue, green and violet, while a yellow pigment green, yellow and orange. So if blue paint is mixed with the yellow, both together will reflect the wavelength common to both, that is green, and so here blue plus yellow will give green and not white as for a spectral colors. Similar to spectral colors, theory for this has been developed in the form of a color triangle. From the triangle for paints, red plus green give black and is not yellow as for spectral colors. Now, colors of heated object. This is based on Kirchhoff's law, that is, a hot object will emit light of that color only which it has absorbed when it was heated. So if a piece of red glass is heated to red hot, it will reflect red and hence in dark will be invisible. However, if it is heated to incandescence, white hot greater than 800 degrees Celsius, it will reflect red in and will absorb all others, so when seen in dark will glow with emission of radiation complementary to red, or white deficient in red, that is cyan or bluish. Similarly, if a blue glass is heated to red hot, it will absorb red and so in dark will appear red. However, if it is heated to incandescence, it will reflect blue in and so in dark will glow with emission of radiation complementary to blue, or white deficient in blue, that is yellow or reddish. Now colors in some other cases. Colors shown by image formed by lenses are due to chromatic aberration. Colors in rainbow are due to dispersion of sunlight by raindrops suspended in air. Compact discs and gratings show colors due to diffraction of light. Colors exhibited by soap bubbles and thin films are due to interference of light. Blue of, blue of sky and red of sunset and sunrise are due to scattering of sunlight by air molecules. Colors shown by orange are due to interaction of cosmic rays with atmospheric gases.